Alright, this is chapter 3, homework number 1. Let's start with 3-9. You're supposed to graph each of these 3 lines on the same set of axes. That just means the same graph. So let's start with this one. This one has a slope of 3, which is just 3 over 1. Remember that slope is rise over run. Then we get our starting value of -3. So we'll start by putting a dot at -3 on the y-axis, and then, following the slope instructions, go up 3 and to the right by 1. Just like in chapter 2. So this is going to be our first line. And then let's try another one. This one is going to have a slope of -2 over 3. So what that tells you to do is -2 means go down 2, but you still go right 3. Down 2, right 3. And this one has a starting value of +3. So let's go there right now. Let's go to +3 on the y-axis. That's my starting value. And then let's follow the instructions from the slope. Down 2, right 3. Alright, and use a different color or label them somehow. You can label them as y equals 3x minus 3, y equals -2 over 3x plus 3, or you can use a different color. It's up to you. Okay, 3-10. AC is a straight segment as shown in the diagram. If the distance between points A and C is 67 miles, determine the distance between points A and B. So we know that from A all the way to C is 67 miles. So here's what we're going to do. We're going to take the distance between A and B, which is 5x minus 2. Then we're going to take the distance between B and C, which is 2x plus 6. And what we're going to do with those is we're going to add them together. And if we add these two distances, it should add to 67. So I know it's a little weird because there's variables, x, but you're just adding together these two distances, add them up, and it should equal 67. Once you do that, it gets a little bit easier. Just make sure you combine like terms. So we have 7x plus 4 equals 67. Okay, and we're going to take away 4 from each side. So 7x equals 63. And then if you divide both sides by 7, x equals 9. Okay, but that's not actually the answer. Not the answer. Let's read the question carefully. Determine the distance between A and B. So how far is it from A to B? Well, it's 5x minus 2 feet. But we know what x is now. So that's great. All we need to do is plug in x. And the distance from A to B is, plug in x equals 9, and you guys can figure that one out. 3-11, evaluate the following expressions. So fun with fractions. Now I prefer to convert these into improper fractions. I'll show you what I mean. 10 times 9 is 90. 9 plus 7 is 97. So fractions like this. You've done it before. That's called an improper fraction. And we're going to add that to 9 times 3 is 27. And then add 2 is 29. So it's -29 over 3. Now since we're adding fractions, they need to have common denominators. This has a denominator 9. This has a denominator of 3. So what we need to do is multiply the fraction on the right by 3 over 3. Okay, so what are we going to get? We're going to get 97 over 9 plus 29 times 3. That's going to be, use your calculator, 87 over 9. And this number is negative. So we're adding together a positive and a negative. All right, so now that they have a common denominator, we're going to just add them straight across the top. 97 plus -87. Right? And 97 plus -87, that is approximately 10. It's just like 97 subtract 87. 10 over 9. Let's try 8. So again, you can do it with mixed fractions, but I prefer to convert it to improper fractions. 8 times 5 is 40, plus 3. It's 43 over 5. This number is negative, and then we divide by 1 times 5 is 5. Add 1, 6 over 5. Okay, so when you have fraction division, what you do is you change the division to times, and you flip this fraction. So it's going to be negative 43 times 5 divided by 5 times 6. Now, you could go through with this, but look, 5 divided by 5, that's just 1. That's a giant 1. You can actually cancel those out. So you can save yourself a little bit of work here if you remember to cancel out the 5s. And the answer is negative 43 over 6, or maybe you want to write it as negative 7 and 1/3. And this one would be 1 1/9. Alright, this one says to draw a slope triangle and use it to write the equation of the line. So maybe I'll help you find the slope and you can write the equation. Okay, so let's figure out the distances here. Okay, so on the x-axis, this triangle goes from an x-coordinate of 2 to an x-coordinate of 4. So the change in x is actually just 2 for this slope triangle. And then in the meantime, y is going from 9 to 16. So y goes up 10, 11, 12, 13, 14, 15, 16. That is a change of 7 units. So delta y equals 7. Now we're going to do a sign check here. This is a positive slope. So the slope is equal to 7 over 2. Alright, so I'll let you finish this one. We have the slope, 7 over 2. We pick a point, either one, and now you write your equation. 319. Determine which transformation was used on each pair of polygons. So I know we really didn't go over this yet, but maybe you remember it from middle school. When you have a mirror image, a mirror image is called a reflection. And that is one that looks like a mirror image. This one is it just gets moved over. So when it gets moved, that's called a translation. And then for C, when you have one that kind of turns, it moves but it turns, this is called a rotation. So maybe there's some point around here, some point in this area where the shape was rotated about that point. So this one looks like it moves but it's turning, so when it turns, that is a rotation. This one looks like a mirror image. So I'll let you answer that one. What kind is it? And then this one again appears to be turned. So what do you call it when you turn a shape? 3-20. Jamila wants to play a game called Guess My Line. She gives you the following hints. 2 points on my line are 1, 1, and 2, 4. Let's graph those. 1, 1, and 2, 4. What's the slope? A graph might help. Well, to get the slope, you could just draw the slope triangles on a graph. You could also use this formula. Since I already drew it on the graph, I'll just finish it. This says a change in x of 1 and a change in y of 3. Right, so my slope, or is 3 over 1. But wait, 3 divided by 1, that's just 3. Okay, what's the y-intercept? Well, following this same pattern, if I went down 3 and over 1, I'd be on the y-axis, right? Over 1, up 3, over 1, up 3. Negative 2. All right, I'll let you write the equation. Tuesday. 3-22. Determine the domain and range of each of the following graphs. Let's start with this first one. Domain is left to right. So as I trace this graph out towards the right, there's an arrow, goes to infinity. And as I come towards the left, this graph goes down, but also it goes left forever to negative infinity. So the entire x-axis gets covered by a domain. This is all real numbers. Now how about the range? Range, we go bottom to top. So how low does it go to how high does it go? All right, so this one has an arrow going down to negative infinity. But if you notice, it comes up here and it kind of levels off at, looks like a 1. So the range is negative infinity to 1. Now a better way to say that is y, since we're on the y-axis, y has to be less than or equal to 1. So this encapsulates the idea of negative infinity to 1, but it uses an inequality, which is preferable. Okay, now let's look at B. So this is the point, a dot, and let's think about domain. Domain is the list of inputs. What can be input to this function? Well, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way out to infinity. So basically it's every number from negative 3 to infinity. And we want to use inequalities, so we're on the x-axis, and we can just say that x is greater than or equal to negative 3. How about the range? The range, how low does it go? The lowest output is negative 2. But negative 2 to what? So this one actually, it looks like the graph is slanting up. This one, the graph levels off at 1, but this one keeps slanting up and up and up and up and up and up forever. So it's negative 2 to infinity. All right, and another way to say that is any number greater than negative 2. And we're on the y-axis. So the range is any number that is greater than or equal to negative 2. It's equal to negative 2 because it passes through that point. It has an output. Negative 3 has an output of negative 2. All right, more fun with fractions. Let's do the subtraction this time. Okay, I prefer the improper fractions, but you can definitely just add them as mixed fractions. So 8 times 2 is 16, and then you add the top, that's 17 over 2, and the number is negative, so let's keep it negative. Okay, and then 3 times 4 is 12. Add the 1, that's 13 over 4. So with fractions, you can't add or subtract unless they have a common denominator. This one is 2, this one is 4. So what we're going to do is multiply top and bottom by 2. 2 times 2 makes 4, common denominator, problem solved. So 2 times 17 is negative 34 is, negative 34 over 4. Minus 13 over 4. Okay, they have a common denominator. Hooray. So now we can just put them over 4 and move these two numbers onto the top of a single fraction. Negative 34 subtract 13. And that is going to be negative 47 over 4. And that's for B. And let's look at D. D, same method. This is going to be 17 over 8. That's a negative number, and we're going to divide that by 1 over 5. Remember to change division to times, and flip 5 over 1. 17 times 5 is negative 85. Negative times positive, negative. And then 8 times 1 is 8. All right, and now if you liked mixed fractions, this was going to be negative 12 and 1/7. And this one's going to be negative 10 and 5/8. All right, this is 324A. So when you have these kinds of problems, it's helpful to write let's start with A, actually. So A, we have 4z to the power negative 3 over 20z to the power negative 1. So we have these coefficients of z. Let's write them as their own separate fraction. And then we'll give z to the power negative 3 over z to the power negative 1, its own fraction. And these are times. They're multiplying each other, right? A number next to a letter means multiply. Okay, so what we can do here is simplify 4 over 20. 4 goes into 25 times, 4 goes into itself 1 time. So that's just 1/5 times. We're going to use the division law of exponents, it says when you divide two terms with the same base, the exponents actually subtract. So it's -3 subtract -1. Now the tricky part about this is -3, it becomes -3 plus 1, right? Subtracting a negative is the same as adding. So this is 1 over 5 times z to the power -2. And when you have a negative exponent, what you do is you cross the line and change the little sign. So -2 is now +2. And then we can recombine our fractions. This is 1 over 5z to the power 2. Let's try C. When you have a power to a power, you're going to multiply. So 6 to the power -3, g to the power 3 times -3, that's going to be -9. So we have 1 over 6 to the power 3, g to the power 9. Same as this one. Negative exponent means have it cross over the line and change the sign on the exponent. Make them both positive. And just a quick note here that 6 to the power 3 is actually equal to 216. Use your calculator. (332). Robert believes these lines are perpendicular, but Marco is not convinced. Mario, what is the slope of each line? Let's call this line A, and let's call this line B. So for line A, make sure you pick a good point, a corner point. Don't pick this one, that's a bad point. Let's get the slope. So this one's negative. Words of slope, dude, that's a negative line. We've got down 3 over 2. So the slope for A is delta y is -3, delta x is 2, and m, or the slope, is -3 over 2. Now let's check B. B goes through this point, it also goes through that point. So draw a slope triangle, has a rise of 1 and a run of 2. This one's positive, it's going uphill. So the slope of B, we've got our delta y of 1 and our delta x of 2. So the slope is m equals 1 over 2. Okay, so now the question is, are they perpendicular? Perpendicular lines have opposite reciprocal slopes. So for example, 1/2 versus -2 over 1, that would be perpendicular. Right? So perpendicular lines have the same slope but upside down and negative. So look at these two slopes. Are they reciprocals of each other? They are not. So we can say slopes are not reciprocals of each other. So lines are not perpendicular. -3 over 2, that would have to be 2 over 3. That would have to meet a slope of 2 over 3 to be a perpendicular. But this is not 2 over 3, so not perpendicular. Okay, 3-33. What we're going to do here is write an expression for perimeter in terms of x. So first of all, this is a rectangle, so that means these two sides are the same length. So x plus 3, x plus 3. If this is 2x, then the other side is also 2x. So the perimeter is when you go around the world and you add up each side. 2x plus x plus 3 plus 2x plus x plus 3. You just add up each side. This plus that plus that plus that, right? That's what I did. Now, what if we know the perimeter is 78? But the perimeter is also this. So what do? We make them equal to each other. 2x plus x plus 3 plus 2x plus x plus 3 is the perimeter, and that's equal to 78. Combine like terms. 2x plus x. So that is 6x plus. Now let's get the numbers. 3 plus 3 is 6. 6x plus 6 equals 78. if I take away 6 on both sides, 6x equals 72. And if I divide both sides by 6, x equals 12. Alright, so what are my dimensions? What does that mean? So the dimensions are 2 times 12, which is 24. And then this is 12 plus 3, that's 15. So the dimensions are 24 by 15. Now I'll let you work on area. Just remember area equals length times width. Right? So we have our length and we have our width. Now check your answer. If you multiply those, do you get 360? Explain how you know this, so make sure you explain. 3-34. Write an equation for the tile pattern represented at the right. So let me write the coordinates of this point first. This is 3, 7. Alright, and now let me make a little XY table. Maybe that'll help. Oops. So x will be 0, 1, 2, 3, 4. Alright, so figure 1 has 11 tiles, and figure 3 has 7 tiles. Figure number is on the x-axis, and then number of tiles is on the y-axis. Now since this is an equation of a line, it has to be consistent. So 11, 7, if this were 9, right? 11, 9, 7, 5, if it went down by -2, it would be consistent. So what does that make the 0 term? Or the y-intercept? 13, right? So we know that the growth of this is -2, because it's going down by 2. And then the y-intercept is 13. Write the equation. 3-36, more of these fractions. Hope you're practicing these. Let's convert to improper and then combine. 3 times 9 is 27, and then if we add 2 to that, that's 29 over 9. That's a negative number, so let's keep it negative. And let's add on to that 8 times 9, which is 72. If we add 7 to that, that's 79 over 9. These already have a common denominator, so that's nice. So put it over 9, and then we just add straight across the top. -29 plus 79. This is the same as 79 minus 29, which is 50. 50 over 9. Now if you like these mixed fractions, let's see. This is going to be 5 and 5/9. Okay, maybe that would have been easier, right? -3 and 8 makes 5, and then -2/9 and 7/9 makes 5/9. Either way. Okay, now let's do the same thing. 1 times 7 is 7. Add 5 onto that, that's 12 over 7 times. 3 times 7 is 21. If we add 6, that's 27 over 7. Since we're multiplying, we don't need common denominators. 7 times 7 is 49. Let's get a calculator. 12 times 27. That's 324. Okie doke, 346. HGJ has been created from ABC. Why is HGJ not a rigid transformation of ABC? Rigid transformations keep the size and shape of an object. So if we go from ABC to JGH, clearly, look at that. The sides change. So since the sides change length, it is not a rigid transformation. But, that being said, something stays the same. So again, since the sides are changing lengths from this triangle to the other, it's not rigid. But something gets preserved, something stays the same. So look at angle B and angle G. What do you notice? They're the same, right? So maybe we can say that the angles stay the same. And if you want to use a fancy word, they're preserved. Angle sizes are preserved. Okay, the perimeter of the triangle at right is 52 units. Write and solve an equation based on the information in the diagram. Use your solution for x to calculate the length of each side of the triangle. Be sure to confirm your answer is correct. So the perimeter, recall that the perimeter is when you add up all three sides of the shape of a triangle, or just every side of whatever shape you're dealing with. So 7x minus 4 plus 10x plus 3 plus 19. Add up the three sides of the triangle. That is the perimeter. But the perimeter is also 52. So we can set them equal to each other. I'll let you finish this one. Solve for x, but also use your solution to calculate the length of each side. So after you get x, make sure you plug it in here and here to get the length of all three sides. So the lengths are 19, and then there's two more lengths that we need. 19 units long, however long that is, and however long that is. 3-48, write the equation of each line described below, a line that goes through these points. So to get equation, let's start by finding the slope. We call this x1, y1, and x2, y2. Right, these are our 2 points. And then let's plug them into the formula, y2 minus y1 over x2 minus x1. So this is going to be 4 minus 10 over 1 minus, careful here, 1 minus negative 7. So we're subtracting a negative number. So 4 minus 10 is negative 6, and 1 minus negative 7, that's 1 plus 7, that's just going to be 8. You're not done yet because these are both even, so let's divide by 2, and we get negative 3 over 4. That's our slope, but we need the equation. Alright, so let's take the slope, and we'll pick a point. Right, and then we'll plug it into this formula, the magic formula, y equals mx plus b. Okay, this is our slope, this is x, this is y. So we've got 4 equals negative 3 over 4 times x, which is 1, plus b. Leave b, b. Plug in 3, leave b, b. Okay, negative 3 over 4 times 1 is just negative 3 over 4. And then we add 3/4 to each side. So this one's kind of ugly. B is 4 and 3/4. So there's our slope, there's our starting value. Y is going to be negative 3 over 4x plus 4 and 3/4. Alright, let's do a couple of these ones. Remember, this is the input, so let's input this into the expression. You replace x with whatever the number is. So 3 times 1 and then subtract 2. This is going to be 3 minus 2. That's the square root of 1. Make sure you subtract these numbers first, then take the square root. Square root of 1 is 1. Let's try 9. Let's input 9 for x. So we do 3 times 9, take away 2, square root at the end. 3 times 9 is 27, and 27 minus 2 is 25. Alright, and the square root of 25 is 5. One more just for good measure. Input 4, multiply by 3, then take away 2. So this is 12 minus 2. This is the square root of 10, which is not a perfect square, so you can leave it like that, or you can get a decimal approximation from your calculator. It's about 3.16. Alright, last one is equation, solve for x. Let's do the fractions. A few tricky ones here. So when you have a fraction on each side of an equal sign, step 1 is to cross multiply.
Alright, so we have 4 times x equals 3 times 8, 24. And it's pretty simple from there. Just divide both sides by 4, x equals 6. How about d? Cross multiply. I'll set this one up for you. You can finish it. 40 times 2 is 80, and then that's equal to 5 times x, which is 5x. Solve for x. X equals... Okay, b. I want to do b because it's kind of tricky. There's a negative sign outside parentheses. Now when you subtract parentheses, you have to distribute the negative sign. So it's minus x, and then minus positive 1. So minus 1. Okay, now we combine like terms. Just on the left-hand side, that's 4x minus 1 equals 5 minus 2x. Now we pick the smaller of the x terms, since there's an x on each side. We cancel it. Make it go to 0. Make a 0 pair. So negative 2x plus 2x, that's going to make that vanish. And we're left with 4x plus 2x, that's 6x minus 1 equals 5. We're almost there. Add 1 to each side. 6x equals 6, and then divide both sides by 6. So x is 1.